Hi, everybody. My name is Eleonora Papaleondiou-Luca, and I'm going to present the topic on the neurological basis of metacognition. In ancient times, Socrates, known as the first great European philosopher and teacher, stated, "Thou know thyself, and thou shalt know the universe and God." In a sense, metacognitive thinking has been already demonstrated across ancient societies. However, the earliest expressions of this idea of an interaction between a subjective self and an objective self could be identified officially through the term of metacognition. Gradually, researchers began to understand that certain activities of consciousness could be studied scientifically using the conceptual framework of metacognition, a term first proposed by John Flavel. Though metacognition has extensively been studied over the last 40 years, its neurological underpinnings have been a rather neglected area of study, which requires a greater investigation. This study aims to investigate how metacognitive knowledge and metacognitive regulation are related with neurobiological findings and consciousness-focused psychological approaches in order to broaden our understanding and further investigation into the discipline. More specifically, it aims to identify and highlight the many aspects and the relationships between neurology and metacognition. Due to the major metacognitive role metacognition plays in learning and education, it also seeks to investigate more deeply how the physical organ of the brain enhances learning, having a profound pedagogical impact and benefits in clinical practice. In a long term, it aims to promote a further and better understanding of the relationships between various scientific fields, such as psychology, neurology, physiology, information processing, learning, neuroplasticity, and self-regulation. Our hypothesis: first of all, metacognition processes are expected to be related at least to certain brain areas, interact with them, and have neurological implications on the brain. Brain activity is expected to affect our metacognitive skills and vice versa. Training in metacognitive skills can affect the morphology of the brain. Metacognitive interviews can be greatly significant not only for students' learning, but also for the brain development. The study investigates how metacognitive procedures are related with the brain based on findings from modern investigational technologies like fMRI, PET, SPECT. Findings are drawn from a wide diversity of neurological studies related to metacognition, executive functioning, self-reflection, self-evaluation, self-development, and self-directed learning. They provide a scientifically grounded approach towards studying the brain and cognition in a way that can be applied to education and learning. The results: findings uncover the neurological underpinnings of metacognition and identify their connection to deeper psychological processes. No one area of the brain has been localized as the center of metacognitive activity. As neurological investigation reveals, instead of a localized brain region being responsible for metacognition, there are in fact many areas involved across various brain regions. However, in many studies, the frontal cortex has been found to play a major role. The morphology, function, and connectivity of frontal areas of the brain have been related to self-reflective metacognitive thinking in both qualitative and quantitative studies. Midbrain and parietal areas have also been shown to play a strong role in metacognitive processing. These studies also highlight the relationship between neurological cognition and broaden the literature of metacognition, as well as the understanding of human capacity for self-regulation. This theoretical framework reveals the viable crossover between various fields, which can support future research in neuropsychology. Moreover, the hindbrain, located at the base of the spine, is responsible for the regulation of subconscious autonomic functions, though to some degree it can play some role in conscious regulation as well. Studies have also shown a close relationship between the size and activation of regions in the AC with metacognitive ability, and other studies have demonstrated that the AC activates most strongly when the test subject is confronted with competing stimuli and require a shift in attentional demands. It has been suggested, for example, that the AC is involved in error monitoring and detection. Neuroplasticity. The brain is far more flexible than previously believed, and metacognition also plays a surprising role in it. Neuroplasticity is the brain's ability to reshape and even heal itself. Neuroplasticity reminds us the well-known phrase, use it or lose it. So cognitive practice in metacognitive self-regulation can become habituated and physically impact all areas of the body. By virtue, humans are able to develop their physical brain in much the same way they can develop their physical body. For example, of individuals using their personal powers of metacognitive regulation to rise even above a disability or adversity. Even patients with brain lesions can demonstrate a powerful level of metacognitive awareness, which can be brought to bear in spite of a serious injury. The brain ability to produce adaptive behavior, even in the face of an extreme neurological loss, shows a remarkable degree of plasticity and an ability to heal itself. Metacognitive regulation plays an important role in the physical and neurological healing by learning and exercise, and can also produce significant morphological changes to the brain. Brain lesion studies. Losses of self-regulation and self-awareness are common features of many brain lesions studies. So the loss or damage of specific areas in the brain has been strongly implicated in very specific functions of metacognitive processes. So lesion studies of the brain often demonstrate impairments of metacognitive awareness, similar to what is seen in Wernicke's patients. For example, damage to the medial temporal area impacts an individual's ability to perceive the speed and direction of something moving. Such brain damages have been also associated with impairments in specific learning disabilities, such as dyslexia, dysgraphia, apraxia, agnosia, or anosognosia, a hemispheric neglect, a condition in which a person suffers from paralysis due to an injury, but seems to be unaware of the disability's existence. However, the ability of modern techniques to fully localize these functions are not clear-cut. Besides, brain damage is rarely a clean or exact. Often brain damage leads to skill deficits that are only partially obscured to awareness. Educational interventions and applications. Several metacognitive educational approaches have achieved success integrating neurological research into their programs. But a neurological explanation of the phenomena of metacognition itself has been elusive. Beyond this, metacognition has been shown to be a defining feature of successful educational programs, and many researchers identify the various ways metacognitive processes affect learning. The fields of both neurology and psychology are uniquely metacognitive and in many ways are formalizations of the basic human cognitive ability. Essentially, any advancements made in these fields is an advancement in our broad metacognitive knowledge as a species. Conclusions. The investigation tried to provide a valuable overview of diverse metacognitive phenomena and their relationship to the developing discipline of information processing underpinning our cognition through the application of powerful new tools of investigation of metacognition. Conclusions uncover the neurological underpinnings of metacognition and identify their connection to deeper psychological processes. Metacognition seems to be associated to both neurological and psychological insights about our mental states. Most importantly, it seeks to take this information one step further by applying it in ways that improve our overall function as humans. This theoretical study reveals the valuable crossover between various fields, which can support future research in neuropsychology. Findings also highlight the relationship between neurology and cognition and broaden the literature of metacognition. Finally, this investigation provides a scientifically grounded approach towards the study of the brain and cognitions that can be applied to education and fundamentally change the way we approach problems of cognitive self-development. So far, we know for sure that the metacognitive activity focuses mainly in the prefrontal cortex, but it traces its way through nearly every level of the brain. However, the neurological underpinnings of metacognition are complex, multifaceted, and presently not well understood. It seems that there are various areas of localization and regions of activation for metacognitive functions and behaviors. Inversely, if metacognition is more the result of large-scale neural networks distributed across the brain, then why is there as much localization as there is in the parietal prefrontal pathway? Perhaps both localized and distributed conceptualization of brain functions are responsible for the relationships between observed neurobiological activity in these cortices and metacognitive behavior. Or maybe we should wait until new research provides deeper levels of investigation and insights. Future fMRI studies could proceed into ever more deep investigations of the relationships between brain form and function. Possibly the most ambiguous goal is to build a network map of the brain's physical connections, a map of the anatomic and functional connectivity of a healthy human brain could lead to important neurological understanding of metacognition, leading to interventions that could improve human learning development, productivity, and mental health in general. Moreover, a deeper neurological understanding of how conscious shifts between subjective and objective stances could provide a measure of metacognitive capacity. While it is clear that damage to some brain regions impacts the performance of a neurocognitive skill, and others the perception of that skill's performance, the cognitive interactions that produce these differences should be a focus of future neurometacognitive investigation. Uncovering the neurobiological basis of metacognition and identifying their connections to deeper psychological processes will be extremely valuable areas of research, unlocking the power of the atom. This investigation could open up our metacognitive understanding and capacity for self-regulation in equally and powerful ways. Such investigations could provide a scientifically more grounded approach towards education and fundamentally change the way we approach problems of self-development in future. Thank you very much.